Hello everyone, welcome back. Welcome to SSC Made Easy. So what are we doing today? Today we are starting with a very fresh topic. It's not a topic, it is a set of topics which is a miscellaneous part. So just to give you a brief, we have done algebra in different parts. We have done trigonometry, algebra for 3 marks, trigo for 3 marks, geometry for 3 to 4 marks. Okay, we have done 90% of all of it. Now we are moving on to a section called as miscellaneous. This miscellaneous will have many parts. Miscellaneous section will have different parts in it. First, there are like around 5 to 6 questions from this. First is time and distance, speed, also trains, also boats and streams, all in the same chapter. Second, profit loss. Third, discount. These are 1 mark questions. One questions going to be asked, each for 2 marks. Fourth, we will see simple interest and compound interest, and we will cover 99% of 2017 questions and some types of all the past year questions, or at least 2016-15 past year questions. What are the different types? Along with this, what I expect you all to do, where you may not require my assistance, which is common for all, but it is always asked, percentage, ratio and proportion, and seventh is based on number system. This and this is what I will take you all through in the miscellaneous part. So today we'll start with time and distance, speed, trains, boat. Just in case if you know it, it's very nice. It's a revision for you. Just in case if you don't know, just wipe off everything whatever you know and pay your 100% attention and see how it is asked in the examinations, or what are the things you need to take care of when we are talking about time, speed. For me, I take it as one chapter which is common for all, for time, distance, speed, for boats and streams, for trains, and for miscellaneous. Okay, all these for me, it is one single chapter, which is speed. Okay, let us start with the very basic. There are a few conditions. Now what I'm doing is I'm explaining you all the basic of speed. What are the different basics which are important only from exam point of view. Okay, now the first thing is we should know what is the formula for speed. Speed is always given as, this is the only thing that you have to remember. Speed is, what is speed? Distance upon time. Now depending on the condition, depending on the situation, depending on the question, this formula would never change, but the theme behind how to find distance, how to find time, it will change. Now let's move on. There are actually, I would say, only 2 to 3 formula that you have to remember, that I will tell you at the end. Now let me first come to the different types. First scenario would be when speed is given, distance is given, you have to find time. Whenever time is asked, it will be distance upon speed. It may happen that you may be given this and you have to find distance. So distance will be time into speed. Only one thing that you have to remember, whenever it is given in kilometer per hour, it is, let's say, 5 kilometers per hour. In order to convert this to meter per second, just remember 5 into 5 by 18. Whatever is given, multiplied by 5 by 18, it will become meter per second, kilometer per hour. How is it? Okay, it is kilometers, which is 1000 meter. Hours is 60 minutes and 60 seconds. If you solve it, it will come down to 2 5s are 2 3s are 5 by 18. Okay, alright. I think you don't need to know anything more than this. And based on the same logic, you can find, let's see how this logic is applied in terms of trains. Let's talk about trains now. Okay, trains, there are 2 to 3 conditions. You don't need to remember the condition number 1, formula number 1, formula number 2, no. Let me first ask you a very simple question. Everyone must have experienced the train journey, right? Whenever a train is crossing another train, though our train is slow, other train is also slow, but suddenly when it crosses, we see that it is fast. We can see the movement as very fast. Or let's say we are running at 80 kilometers per hour, there is one parallel track, another train is also coming in the same direction, but it is moving at 90 kilometers per hour. But the moment both of them are parallel, it would look as if it is going very slow. This is a practical experience. For this, you should have traveled through trains. In case you haven't, no, not an issue. Even if you are in a car, if you have a car, and if you are in a car, then, or if you are in a bus, if two things are traveling in the same direction, irrespective of their speed, what speed this is at, what speed this is at, you will find that in the same direction, the movement looks a bit slow. And whenever it is opposite direction, the movement you will find it's at the light speed. So it means what? It means if a train, this is supposed to be a train, okay, if a train is moving in this direction and if another train is moving in this direction, if the speed of this train is x, if the speed of this train is y, if both of them are in opposite direction, then actually the speed, you are sitting here, you're sitting here and you're seeing the view. The person who will see the speed, it would not be x, it would not be y, but the person would see the speed of x plus y. This is known as relative speed. And the same thing, if there is another track, on this track another train is going in the same direction as this train, and this is traveling at z, then person sitting over here or person sitting over here will see the relative speed as x minus z or z minus x, whichever is more, that has to be subtracted because speed can never be negative. So the relative speed, when the things are crossing each other, you see it as faster. When the relative speed, when it is in the same direction, then you see the movement as slow, so it has to be subtracted. Same logic, I hope you have understood till now. Okay, clear? Same logic is applied in boats and streams. What happens in boats and streams is that in boats, another nice boat, but this night boat, the way is gonna be slanting and it's gonna go downwards. Okay, so if its speed is x and the speed, because of this tilt, if the speed of the stream is y, then actually after this position is crossed, this is known as downstream. So after this position is crossed, actual speed of this, the relative speed will become x plus y. And when it is traveling from here, both in this direction, then it would find it very difficult to move in the opposite direction. So the relative speed will be x minus y. What is x? The speed of boat. What is y? The speed of stream. That's it. No rocket science. Same logic of relative speed been applied. Same thing has happened in scenario based questions. What happens in scenario based questions is, there is one thief, okay, and here is one policeman with a hat, and the thief has stolen something and starts running, and this person sees the thief, he has seen it, and the moment he starts running, after a few seconds this person starts running. So this person's speed is x, this person's speed is y. Both are running in same direction. So relative speed will be x minus y. Whichever is greater will be minus. If policeman wants to catch this person, his speed has to be more than him. Only then he will be able to catch. Otherwise it's understood. Now, I hope this logic is clear. Once we apply this in sums, then you will understand that actually it's not upstream, downstream, it's not this direction, that direction. It is actually very simple, and it has always been this simple. Now, one more thing. In terms of train, one more logic. There is always a discussion of poles and platform and things like that. These are very standard and common question. Now when a train is crossing a pole, I don't know if this side is visible. Okay, if it's crossing this pole, it's moving in this direction. It is moving in this direction, it has crossed with a good amount of speed in this direction. But what is the distance it has traveled while crossing the pole? The distance that it has traveled while crossing the pole is nothing else but the length of the train. This much length of the train is the distance traveled when it is crossing a pole, or when it is crossing a man standing on the platform moving in this direction. If it is moving in opposite direction to the train, then relative speed will be speed of man plus speed of train. If he is moving in the same direction, it will be speed of train minus speed of man. You don't have to remember it as a formula, just remember it as a logic. Now, when it is crossing a bridge, this is a bridge, okay, it's a very strong bridge which will not fall, and the train is about to pass from here. If someone has to say what is the distance traveled in this case, it has traveled the distance of the bridge plus it has traveled itself distance, because it's not one single bullet passing through this, it is the entire train. It has to cross the entire length of its own. So the distance in this case will be length of the bridge and length of the train. In the case of a pole, it will be length of a train. In case of a platform, when it is crossing a platform, it will be length of platform plus length of train. Just remember these logics, these basics, and now let us start with some sums. And once you see how this logic is applied, then you will understand that it is easy and it's not at all difficult. Okay, so let's begin with some sums. Kindly take a screenshot if you wish to. Alright, I hope you have taken a screenshot. Let's see some examples now. As I said, these are purely based on the logic which I have just explained. Kindly, these are past year questions of 2017. 16th of August, shift 2. Question number 59. 59 means in all the sets you will find 59 question of speed and distance. Okay, let's see. Two trains moving in opposite direction at 30 km per hour and 45 km per hour respectively of the length for 450 meters and 550 meters respectively. Find the time taken by slow train to cross the fast train. So there are two trains now. Two trains, one is fast, one is slow. First question, what is asked? Find the time taken. We have to find the time taken and I have to find the marker. Okay. Time taken by, what is the time taken? So we know that speed is distance upon time. So time is distance upon speed. What is the speed? What is the distance first? In case of two trains which are moving in opposite direction, how much distance do they cross? They cross the distance of each other's length. So it is 450 plus 550. Okay. So this is the distance, which is 1000 meters. Now what is the speed? Whether be it slow train, be it fast train, relative speed will be the same. So relative speed for the slow train, it will be, they are moving in opposite direction, so it would not look, the passenger sitting inside this train would not find the relative speed as 30 because they are traveling at 30. It would look at 30 plus 45, which is 75 kilometer per hour. Now it's such a simple question. Distance is 1000 meters, speed is this, how much is the time? So kindly solve it. It will be 1000 divided by, this is relative speed. So it's nothing else, 1000 divided by 75. Now 1000 is in meters, this is in kilometer per hour, and we have to, crossing of train would not happen in hours. Crossing of train would happen in seconds. Options are also given in seconds, and options given, I'll let you all know. So this we have to convert into meter per second. I have just now explained it to you all. Into 5 by 18 will convert it into meter per second. Into 5 by 18 will convert this. So 25 3, 25 40, 5 8, 48. So it is in 48 seconds the trains will cross each other. In case if you don't know the logic, you will remember the formula x1 minus y1 x2 y2. No, it is just, at least in CGL you would not have to, at least in CGL tier 1 you would not have to remember all those formulas. Okay, now next one. This is another difficult one. Looking difficult, but actually it's not. A runner starts from point A at 6 a.m. with 8 km per hour. Another racer starts from the same point at 8:30 a.m. So person is starting at 6 a.m. in the morning. Nice runner. Another runner waited for 2.5 hours and then started at 8:30 in the same direction. At what time will the second runner overtake the another one? Because the second one is running at 10 km per hour. No matter if the race is over, no matter the day is over, but because this is at a higher speed, so definitely it has to overtake. So first thing, what is asked? Time. What is the formula? Formula is speed is distance upon time. Time is distance upon speed. How much is the distance that second person has to travel? We don't know. But we know one thing, that we know that this person has started at 6 and this person is starting at 8:30. It means in 2.5 hours, how much distance can this person travel? That would be the distance that he has to cover. Logic, once again, this is a runner starting at 6. This is another runner starting at 8:30. Points are same. How much distance he would have covered till 8:30, from 6 o'clock till 8:30? That is the distance which he has to cover, second person. Okay, so at the rate of 8 km per hour in 2.5 hours, 8 km in 1 hour, 16 km in 2 hours, 20 kilometers in 2.5 hours. So 20 kilometers is what the second person has to cover. But has the first person stopped? No. So what will be the speed? So distance we have found that it is in 2.5 hours from 6 to 8:30 he is traveling 20 kilometers. So this is a distance which our second racer has to cover. What will be the speed? He is running at 10. But is the other person stopping? No. So these are two trains moving in the same direction. When they are moving in the same direction, no matter what is your speed, what is other train's speed, relative speed, because both are moving, it will be x minus y. So though he is running at 10, but relative speed will be 10 minus 8, which will be 2 km per hour. So we have got the distance, we have got the speed, so it will take 10 hours. This is a distance, this is a speed, it will take 10, this is time, 10 hours. So when will he overtake? 8:30, 10 hours will be 6:30 in the evening that person will overtake. Is it a rocket science? No. I'll explain again. Person is starting at 6, another person is starting at 8:30. From 6 to 8:30 this person was relaxing and this person was running. So from 6 to 8:30 for 2.5 hours at the rate of 8 km per hour, this person has covered a distance of 20 kilometers. Why? Because 8 km in 1 hour, 16 km in 2 hours, 4 km in half hour, 2.5 hours, 20. We have to find time. Time is distance by speed. Because speed is distance by time, so time is distance by speed. What is the speed? Because this person has to overtake 20 kilometers. He has to cover 20 kilometers. Though he is running at 10, but what will be the relative speed? Because both the trains are moving in same direction. Both the cars are moving in same direction if you have not traveled by train, and if you only travel by car, then both the cars, if they are moving in same direction, it is irrespective of your speed, you will find that the relative speed is difference of the speeds. So it is x minus y, so relative speed has to be 10 minus 8, which is 2. So at this rate you will get 10 hours as your answer. So from 8:30 am he is starting, after 10 hours means 6:30 pm he will overtake. Alright, now let's look at the next one. Okay, diameter of a wheel is 21 centimeter. This is a question wherein the examiner has tried to check both of your skills, geometry also and speed topic also. Diameter of the wheel is 21 centimeters. Cyclist takes 45 minutes to reach the destination at 16.5 km per hour. How many revolutions will wheel make in the journey? First of all, you should know that one revolution is completed. This distance, if we cut this wheel and if we make it straight, rubber, actual distance will be, this is calculated by 2 pi r. This is known as circumference. So one revolution is 2 pi r. Pi is 22 by 7. 2 into 22 by 7. What is the radius given? 21. So it is nothing else but 3. It is not radius, diameter. So radius is 21 by 2. So it is 66 is one revolution. 66 centimeter. One thing. Now, how many revolutions it will take? what is the distance this cyclist has traveled from here till his destination. So those many revolutions. We will divide that distance upon one revolution. If one revolution of a wheel is 66, then 660 kilometers, 660 centimeters will involve how many revolutions? It will involve 10. How? Divided by 66. So we will find the distance, how much distance the cyclist has travelled, and we will divide that by one revolution value, which is 2 pi r. Not getting it? Not a problem. One revolution is circumference, which is 2 pi r, which is 22 by 7 into 21 by 2. This is 66. So one revolution is 66 centimeter. How many revolutions we'll make in the journey? What is the journey he has done? He has done 16.5. So we have to find distance now. Speed is distance by time. I know only one formula. What we have to find now? Journey distance. So distance will be speed into time. What is the speed? 16.5. I will make it to 5 by 18 to convert it to meter per second. What is the time? Time is 45 minutes. 45 minutes I will multiply it by 60 because units are in meter per second. So minutes has to be converted to seconds. This is the distance. I will divide this by 66 and these many revolutions will be there. This will be the answer. So it was only equation you should know how we have to form. Once the equation is formed, you will cancel it out and a lot of things are getting cancelled. 6 3s are 11, 6 are 11, 15s are. So you can solve this on your own. I hope you have got the logic. One revolution is circumference, and so journey is how much time, how much distance he has travelled. I know only one formula. Speed is distance by time, so distance will be speed into time. Speed is given 16.5, time is given 45 minutes. I will make sure that all the conversions is in the same units, which is meter and seconds, and then I will find the answer. Alright, I hope you have got this. We'll see some more examples of it. Kindly take a screenshot. Right, I hope you have taken a screenshot. Now let's see the next 3 examples. Again, very simple. We are using the same logic. Alright. Okay, so this is 2016 tier 1 question. Sound travels at 330 meter per second. Everyone knows. How far is thunder cloud if sound is heard after 10 seconds of seeing the lightning? There is a lightning and the person has seen the lightning, thunder through the thunder clouds, but the sound is heard after 10 seconds of seeing the lightning. So they want to know how far is the thunder cloud, what is the distance. I know only one formula, but which is speed is equals to distance upon time. What is asked? How far means distance. Distance is speed into time. What is the speed? Speed of sound is 330 meter per second. What is the time? 10 seconds. So what is the distance? 3300, which is 3.3 kilometers. Alright, that is the answer. Okay, no rocket science, it's a very simple question. 2017. After repair, scooter runs at 54 km per hour. Before repair, it used to run 48 km per hour. It covers a distance of 6 hours after repair. how much would it have covered before the repair? The same distance. So now the story is, before repair the mileage was 48. After repair it is 54. They want to know how much it would have covered. I know only one formula. Speed is distance upon time. I want to know the distance. So distance is speed into time. How much has it actually covered in 6 hours after repair? Time is 6 hours. Speed is after repair is 54. So actually it is 5, 6, 33, 24 kilometers it is covering. Now same distance it has to cover before repair. This is a distance. So how much time? Time is required. So time is distance by speed. So distance which it has covered after mileage is 324. Same distance it has to cover, but at older speed. This will be your answer. So whatever time it is, please do the calculations. Three 109. Kindly do the calculations. It is will come after checking the options. You can check, but this is how you have to solve. All right. Okay, next one, the last one. And just be careful that you have taken everything in terms of meter and kilometer an hour. Okay, you can solve that. Whatever is the answer, that will be the answer. Okay, now the last one. A starts from point A at 30 meter per second. After 3 seconds, B starts chasing with 50 meter per second. What is the total distance traveled by A and B before A is caught? So the scene is, A is standing nicely and then suddenly starts running. Not nicely, but at the rate of 30 meter per second. After looking at him, B takes 3 seconds to react. What has happened? And then after 3 seconds, he realizes that the A has started running, so he starts chasing him. So of course he sees in 3 seconds that what is his speed. He sees that he is running at 30, so he starts at 50. B starts at 50 meter per second, and he is not running in opposite direction. In order to catch him, he has to be in the same direction. So what is the total distance traveled by A and B before A is caught? So first of all, let's see when it is caught. How much is the lag? After how much time has B started? After 3 seconds. So first of all, in such scenario, we should know how much time distance he has to cover. What this person has already covered. First person has already covered the distance for 3 seconds. So 30 meter it travels in 1 second. That is the speed of A. So in 3 seconds, how much distance is it traveling? 90 meter. So that is for sure he is 90 meters behind. So he has to cover 90 meters in order to catch him. What will be the speed? As we all know, going in same direction, train traveling or car traveling, it has to be relative speed. So speed will not be 50. Speed will be 50 minus 30, which will be 20 meter per second. Alright. So I know only one formula, which is speed is distance by time. So time is distance by speed. Distance is 90 meters. Speed is 20 relative speed. So time is 4.5 seconds. Now it is for sure after 4.5 seconds that person is going to be caught. Okay. But they are asking what is the total distance traveled by A and B before A is caught. So distance traveled by A for how long? For how long story that was? It was 4.5 second story. So for 4.5 second, how much distance would he travel? I know only one formula. Speed is distance by time. So distance will be speed into time. Speed is 30, time is 4.5. So 30 into 4.5 will give me 5 3s are 15, 3 4s are 12, 13, 135. I hope so. 120. Yeah. Similarly, this person, 4.5 seconds B has taken to catch him, but A had already started 3 seconds back. So for A it is not 4.5 second story. For A it is 3 plus 4.5, which is 7.5 second story. So the total distance traveled by A is 7.5 seconds. So in 7.5 seconds he is traveling this much, which is 5 3s are 15, 7 3s are 21 plus 1 22. 225 meters he has traveled. Similarly, how much has B traveled? For B it is 4.5 seconds. His speed is 50. So it becomes 5 5s are 25, 5 4s are 20. 225 meter even he has traveled. He has also traveled the same. Of course it has to be the same. So we'll add it. It will become 450, and 450 meters is the answer. I hope you are getting the logic behind these sums. It's very simple. It's just that your basic has to be very clear. Initially, if you're taking a long time, that's okay. But you need to develop a mechanism of understanding the question and then doing it, rather than by hearting the formula. So whenever you see, at least for tier 1 till tier 1, there would not be any rocket science applied, only basic logics. We'll see. I'll try to cover as much as different types as possible, and we'll continue with the same speed, time and distance. We'll try to see some more questions of trains, some questions of boat and streams, some questions of average speed, and that's about it. Whatever is the maximum possible types which are expected, that I will try to cover. And then we'll see with the further topics of profit and loss, discount. You will not miss out on these marks. That is my objective. Speed, 1 mark for sure you will get. Average for sure, percentage for sure, profit and loss for sure, and discount for sure. So at least 5 to 6 marks for sure you will get it in the miscellaneous section. 4 marks in DI, 3 to 4 in geometry. So my objective is to make sure you are crossing at least more than 20 to 25. So let's see, let's hope for the best. Kindly take a screenshot and do practice, and stay tuned. We'll continue with the same topic next time. Thank you so much.